We want to look at the effects of an increase in the population or labor growth rate in the Solow model with population labor growth but no technological progress. So we're going to start off with the steady state. Um, so economy begins in steady state. So we're going to start the analysis from the steady state. This is going to be point A. I'm going to show this in the diagram where we know K is equal to capital per worker is equal to K star and Y is Y star. And it's depicted in this diagram as well. In this diagram, our initial break investment per worker is delta plus NK. Output per worker is FK. Investment per worker is SFK, right? SFK, right? So let's just label all of this as Y. Now we're saying the steady state, we know graphically steady state value capital per worker graphically is at the intersection of the investment per worker curve and the break-even investment per worker line. Right, so this is our steady state value. K is equal to K star, so this is point A. And we know once we have the steady state value of capital per worker through our per worker production function, which is represented by this curve here, the output per worker curve, we can find out steady state value output per worker, right? We just plug in the steady state value of capital per worker in our per worker production function, right? So through our per worker production function, the output per worker curve, we can find the steady state value of output per worker as well, right? So we have this initial steady state A at the point of intersection of the break-even investment per worker line and the investment per worker curve, which gives us a steady state value of capital per worker. And through our per worker production function or this output per worker curve, we can find the steady state value of output per worker. Right, so now let's say n increases to n prime. N here represents n in our break-even investment per worker line, and this break-even investment per worker we know is delta plus n times small k, right? Small k is capital per worker, delta is the rate of depreciation, n is our population labor growth rate. So we're saying this population labor growth rate increases to n prime. So now what this does is this increases the slope. So this increases the slope of our break-even investment line. Increase in the slope of our break-even investment line, which rotates upwards. It's not a parallel shift because the slope is changing, right? Which rotates because the slope is we know delta plus n, which rotates upwards, not a parallel shift, right? Change in n or either change in delta is not going to be a parallel shift because the slope is changing, right? So we have a new break even. So this is like the old break even investment per worker. Now we have a new break even investment per worker. Let's make that. So here we have a new break even investment per worker. So, oh, sorry. So this is the new break even investment, right? Investment per worker, which is going to be delta plus n prime k, right? So this is the new break-even investment per worker, delta plus n prime k, right? So we can see the slope has gone up from delta plus n to delta plus n prime, where n prime is greater than n, right? Because the slope has gone up, it has rotated upwards in this manner, right? So this is what has happened now. So now let's look at the effect on K. Right? Let's just delete this so that we have more space to work with. So we started off in the steady state A, and then what happened was N went up, and this caused the break-even investment line to rotate upwards, like we can see over here. So now let's see what is the effect on capital per worker. So effect on small k. Now we'll see at the current value of k. We started off with the steady state. At the current value of k, i.e. k is equal to k star. So because we start current value of k is just the initial steady state value of k. So we can see at this current value of k, if I say this is O and I call this B prime, right? So at the current value of k, we'll see, can you break even investment per worker? I'm gonna write this in short form. New break even investment per worker, which we know is delta plus n prime k star, right? This is the new break investment per worker at the value k is equal to k star. It's delta plus n prime k star because we're plugging in k is equal to k star over here. Is greater than investment per worker, which is just going to be SFK star, right? Because we're looking at this value k is equal to k star. At k is equal to k star, so this is delta plus n prime k star, and at k is equal to k star, this is SFK star. Right, and if you look at it in terms of heights, so the new break-even investment per worker is just OB prime, right? It's this much distance starting from here to here at the value k is equal to k star, right? So this is OB prime. Our investment per worker is just this much distance OA, right? So this is this. So basically the idea is that at k is equal to k star, the new break-even investment line is above investment curve, right? Is above the investment curve, right? So we can see at the current value of k that we started off with, k is equal to k star, the initial steady state value, the new break-even investment per worker, which is OB prime, exceeds investment per worker, which is A. So delta k, which is change in capital per worker, which we know is equal to investment per worker. Now this is through, we know, our capital accumulation equation, minus break even investment per worker is going to be less than zero, right? We can graphically also see this. This we know is the difference between investment per worker. Investment per worker is OA. Break even investment per worker is OB prime. So it's OA minus OB prime. So this much is how much new break even investment exceeds new break investment per worker exceeds investment per worker. So delta k is less than zero, right? This represents a negative delta k because we're doing OA minus OB prime, right? So this is change in capital per worker over here, right? So new, because this is the amount by which new break even investment exceeds investment, new break even investment per worker exceeds investment per worker. So this is delta k, which is less than zero, right, over here. Since delta k is less than zero, thus change in capital per worker zero, thus k decreases from k star, the initial steady state value of k that we started off with, until economy reaches new steady state at k double star, where new break even investment per worker, sorry, is equal to investment per worker, right? So, and this is going to be this point, right? Over here with the new break-even investment per worker line and the investment per worker curve, right? Basically intersect, right? So basically, so when we're looking at the change in capital per worker, what happens to capital per worker? So we're looking at, okay, you start off with at k is equal to k star, and then when break-even, when the population growth rate increases, that causes the break-even investment line to rotate upwards. As a result of that, at the current value of k, or the initial value k that we started off with, which is the steady state value of k, break-even investment per worker exceeds investment per worker at this value of k, where we can see that this is the amount by which it exceeds, right? So this is change in capital per worker, which is negative. And as change in capital per worker is negative, it's going to cause capital per worker to go down until you reach the new steady state at k double star, where the new break-even investment per worker is equal to investment per worker, right? So this is for this. So now let's look at the effect on y. Oh no, we do not want to delete this. Let me do this here. So now we looked at what happens to capital per worker. Now let's look at the effect on output per worker. Now since y is a function, positive function of k, right? So it's a positive function of k. Since y is a positive function of k, which basically means that output moves with a capital. I think just a plus here would be fine if I just wait. So output is a positive function. Output per worker is a positive function of capital per worker. So this means that output per worker moves with capital per worker. So decrease in k from k star to k double star will cause corresponding decrease in y. So the corresponding decrease in y from its initial steady state value y star to the new steady state value y double star, right? So a decrease in k. So we know output moves with capital. So if capital per worker decreases from k star to k double star, there will be corresponding decrease in y from y star to new steady state value y double star, right? And this is essentially represented by a movement down the per worker production function. Movement down the per worker production function, right? Which is represented by this, like, which is this output per worker curve, right? So you start, so basically, output is moving capital per worker. K is going down from K star to K double star. As a result, let me just erase this bit to save more space, right? So basically, what we're saying is, okay, because output moves with capital, so when K goes down from K star to K double star, output also goes down from Y star to Y double star. And this value Y double star, again, we know K at this point, at the new steady state value, which is like A prime, K is K double star. You can plug this in your per worker production function to get Y double star on your output per worker curve or the per worker production function. So Y is going down. So you have a movement down the per worker production function, right? So because output moves with capital, so as k goes down from k star to k double star, y goes down from y star to y double star. So what we're saying is, okay, so in the new steady state, which is at a double prime, we have k is equal to k double star and y is equal to y double star, and both of them are lower than their initial steady state values, k star and y star respectively. So new steady state is a prime, which is at the intersection of the new break-even investment per worker curve and the investment per worker, sorry, break-even investment per worker line and the investment per worker curve. New steady state is at A prime with K is equal to K double star less than K star and Y is equal to Y double star, which is less than Y star. So Solow model predicts that countries with higher rates with higher rates of population or labor growth will have lower levels of capital, will have lower levels of capital per worker, and therefore lower output per worker in long run, right? Steady state is the long run outcome of the Solow model. Right, so what the Solow model predicts that for countries that have higher population or labor growth rates, will have lower levels of capital per worker and therefore lower output per worker in the long run.